Yeah, we're looking at the third rule for solving partial fractions. Okay, simple rules. The third rule is this: to each quadratic quadratic to each quadratic factor to each quadratic factor of the form ax squared plus bx in the denominator. Okay, which cannot be factor, which cannot be factor, which cannot be factor or factorized. Okay, which cannot be factor or factorized. Okay, they correspond. They correspond. They correspond a partial fraction, partial fraction of the form um, ax plus b over your quadratic bx plus c. Okay, so that's that. Another rule is this: if the quadratic in the denominator is repeated like this form plus c, if this is repeated in power 2 or power 3 in the denominator, which cannot be factorized, okay, in that case now we are going to have a partial fraction of the form ax, this is 4, ax plus b over your ax squared plus bx plus c, then plus the next one, that will be what? Cx plus d all over ax squared plus bx plus c power 2. Okay, if it's 2, if it's 3, then you continue and do the third one. Okay, so and that's that. In a nutshell, if you have a quadratic which you cannot factor, okay, then it will be expressed in this form where your numerator is a linear one. Okay, then another one you can have if you have repeated linear factor at the denominator. Repeated linear factor at the denominator. For example, now maybe you have x minus a power 3 or power 4. Okay, so this will correspond to what? This will correspond to a partial fraction of the form a over x minus a plus b over x minus a power 2, then plus c over, you stop at the last one, power 3, s minus what? S minus power 3. If it's 4, you continue and stop at the power 4. So that's that on these aspects. So let's look at the questions. So resolve into partial fraction. Resolve into partial fraction. We have this. Check this question. First observation: the degree of the numerator is less to denominator. So there won't be division here. Okay, there won't be polynomial division. Okay, so this will just resolve into what? This will resolve into 3x squared plus 8x plus 13 all over x minus 1 x squared plus 2x plus 5. This one is a linear factor, and that will be what? A over x minus 1 plus. This is a quadratic, which you cannot factorize. You can turn it to linear factor, and that will be equal to what? Bx plus c all over x squared plus 2x plus 5. Okay, and then you have to check, since you have a here, then the next constant will be what? B and c. B times the variable you are using plus what? Constants. Then multiply through the equation, multiply through by the common factor here, x minus 1 into bracket x squared plus 2x plus 5. And that will be equal to what? 3x squared plus 8x plus 13 equal to this one times this one, a into bracket x squared plus 2x plus 5, then plus this one times this one, x minus 1 into bracket what? Bx A plus C. So that's what we have now. Then what can we do? We can solve it in many ways. But one of the ways is just to equate coefficients. You can equate coefficients, equating coefficients, or equate coefficients of the variable. For the s squared now, coefficient of s squared on this side, on the left hand side, that's what, 3. Here we can expand this. This will be as squared. This one times this one, that's a 2 plus 2ax, and then plus 5a. Okay. Then plus this one times this one, that's a plus bs squared, plus cs. Okay, and then minus times this one, minus bx, minus c. So for the f square, we're having a plus b, the coefficients, a plus b. That's equation 1. Equation 2, we can equate coefficient of x in this case, and that will be what? On this one, coefficient of x is what? 8, equal to, that will be 2a plus c, plus c, 2a plus c, and minus b, equation 2. Constant times, that's 13, equal to 5a minus c, equation 3. So these are 3 equations we can form. Okay, but before we can use any of this, we can quickly, from here, let x be equal to what? Let x be equal to 1 from here. If x is 1, this expression will go. Then we can have what? We can have 3 plus 8, and then plus 13, which will be equal to 24, equal to 24 equal to a into brackets 1 plus 2 plus 5, that's 8. So a is what? 24 over what? 24 by 8, that's 3. So from there, we can come here and get b. From here, we can come here and get b. So that will be equal to what? 3 equal to what? A plus b. And my a is what? 3 plus b. So b is what? 0. So let's see equation that involves c, which is the third one. We can use the third one, we can use the second one, okay, for the constant times here. So that will be 13 equal to 5a minus c. 13 equal to 5 times 3 minus c. So 13 equal to 15 minus c. And that was minus 2 equal to minus c. So c is what? C is 2. So final. The question we are given will now be equal to, our question will be equal to, a is what? A is 3 over x minus 1, then plus b is 0, and that will be c. Our c is what? 2 over what? S squared plus 2x plus 5. So that's the answer to that question. Resolve this into partial fraction. Yeah, if you look at the questions, it contains, this is a linear factor, and this one is a quadratic, which you cannot factorize. Okay, so the solution will now become 2x squared plus 2x plus 10 all over x plus 1 into bracket s squared plus 9. And this will be equal to your a over is a linear factor, s minus 1, I mean this one, so s plus 1. Then this one is a quadratic, and that will be what? B x plus c all over what? S squared plus 9. Multiply through by what? Multiply through by x plus 1 times s squared plus 9. So that will give you 2x squared on the left hand side plus 10 equal to this one times this one, a to bracket s squared plus 9, and then plus x plus 1 into bracket bx plus c. So that's what we have here. We can quickly expand this. This will be equal to ax squared plus 9x plus 9a plus this one times this one plus bx squared. This one times this one plus cx plus 1 times this one bx plus c. Okay, so we can have now we can have a plus b s squared. Yeah, this one can be combined together. Then we can have plus x into brackets c plus b. Okay, and then we can have the constant times 9a plus 9a plus c plus 9a plus c. Okay, equal to what? 2x squared plus 2x plus 10. Okay, so let's begin to equate the coefficients. Let's equate the coefficient of s squared. Equate the coefficient of s squared. On the left hand side we have 2, and this will be a plus b, equation 1. For the coefficient of x, we have 2 here also on the here. The coefficient just attachment to the coefficient of x here is xc plus b, c plus b. Okay, that's that. Equation 2. Then the constant terms, those ones that has no variable, that will be what? Constant terms. The attachment, the constant terms on the left hand side is 10 equal to what? 9a plus c, equation 3. Okay, but then you have 2 here minus 2 plus 10 equal to 10a. So that will be a is 1. So once we've gotten that, we can use end of the equation to get can use this first one to get a b. So 2 equal to what? A plus b. That's equal to 1 plus b. So b is equal to what? 1. We need c also. We can use either 2 or 3. Okay. 2 equal to c plus b. 2 equal to, my c is what? We don't know, but we know b. So c also is also 1. 2 minus 1. So we've gotten all the constants. So our answer will now become the question 2x squared plus 2x plus 10 all over x plus 1 into brackets x squared plus 9 equal to, my a is what? My a is 1 over x plus 1 plus my b is 1, that's x plus c plus 1 over x squared plus 9. And that finished that question. Okay? In a nutshell, it's very simple. In a nutshell, just try to interpret the question. This is linear, this is quadratic. And this quadratic, you can factorize it. So for linear one to be over the linear, for the one you cannot factorize, it should take the form of this. Okay, when you have a quadratic and you cannot factorize it, then it's going to be of this form: b of the variable plus another constant. Okay, then multiply through by this the common factor here, and that's what we have done. Okay.